All right, today we're going to look at 2.1 graphs of equations. So we want to be able to look and see, no matter what type of equation we get, how to get a basic graph of those items. So let's look at a few definitions, and then we will get into graphing here. Okay. All right, so definitions. So our first definition is called the Cartesian coordinates system. Now, you may have also heard this as the rectangular coordinate system, or just simply the XY plane. That's the names for it, okay? But it is called the Cartesian coordinate system. Descartes discovered this or came up with this, and so he got to name it. So they typically put their name on those types of things. All right, so I kind of mentioned it's the XY plane. So we have these two, what we call axes that go forever. We have arrows here on the end of these to represent that they go forever. This horizontal line is the x-axis, and this vertical line here is the y-axis. Okay. Here in the middle, we have where they cross. This is called the origin. And it's the ordered pair, 0, 0, okay, for those. Now on these usually have dashes, 1, 2, 3, 4, and that is a numbering system. It's just like a number line for those. So this would be represented as 1, 2, 3. And when we go the other direction, those are -1, -2, -3. We can also go on the vertical line, the x-axis, up is positive and down is negative. Okay, and those go forever there on those. These are also broken into quadrants, quadrant 1, 2, 3, and 4. I'm not going to write that down. We're not going to have to really deal with that here in this course, but if you move into a higher course, it is important to know what quadrant things are in, because it can tell us different things, especially if we're looking at like trig and those types of things. It's important to know what quadrant something is in. Okay. All right. Our other definitions: graph of an equation. This is a drawing that represents, let me spell that correctly. Try again here. Represents all of the solutions of the equation. So once we put a line or a curve or anything on this graph, that's going to represent all of the possible solutions to that equation. So that's when we draw a line, because there's an infinite amount with those pieces. Okay. All right, so let's get into the examples here and see how to graph different types of equations. Now, I'm going to stick with a very basic way today because we're not very far into this. There are many different ways of graphing. We're going to look at some other ways throughout the semester based on the type of equation. But we want to look here today at some simple ones. I actually almost forgot, before I get into actually graphing, let's look at some basic shapes so that when we see the equation, we'll know what it should look like for the most part, okay? And so really this would be definition number 3. So I apologize there. Parent functions. Now that word function, we're going to use that in relation to equation for right now. We'll come back and define that word later on. It's not a big deal at this point. So don't worry about that word just yet. We'll talk about it later, okay? All right, so our first one here, y equals x. Okay, y equals x. Make that look like a y here. I'm struggling this morning. Y equals x. This is our most basic. It is what we call linear. And so the graph of this one here, my blue marker, there it is what many of us say is a straight line. It has some type of slope to it. It may be turned, it may be flat, different things like that on those. But it has this straight line, no curve to it shape. Okay. And so if we see just a y and x, there may be numbers added or multiplied, but no powers and no other symbols in there, then we know that it's going to be a straight line. Our second one here, y equals x squared. This is called a quadratic. Okay. So its basic shape, you've probably heard of before, and that's called a parabola. And it's this U shape. Okay. Now it can be flipped over, it can be moved around, but that's the basic shape of it. It's going to take this shape and move it or manipulate this particular shape. And so if our biggest power is a 2, nothing bigger than that, but we at least have a 2 and no other symbols, then it is called a quadratic. Y equals x to the third. This one is called a cubic. Okay. And so its basic shape, it's going to go up over here, but down here, it's going to be going down for those pieces pretty quickly. So it has that little roll to it. Now it can almost look like a roller coaster sometimes. It can also be going downhill for those. But again, this is our most basic shape for that. Okay. Our next one, y equals the absolute value of x. So if we remember, those bars mean absolute value. Absolute value means it turns whatever's inside after you've done any math work with that positive for those pieces. Okay. So this is absolute value. All right. And one of the good things about absolute value is because it's always going to be positive, it's going to end up, at first we think it's just straight line, but it's straight lines like so. It creates a V shape. And so if you remember absolute value, value starts with a V, then it's going to give me a V shape. So that's one way that you can remember that piece. Okay. All right, and then E, y equals 1 over x. 1 over x. This is called rational. The term rational means fraction. And so that's why it's called a rational. And this one's going to be probably the weirdest one of all of them. It can get really weird based on how big or ugly our equation is. We're not going to deal with a lot of that. But up here, it's going to give kind of this saddle, and then it's also going to have one down here. So it's going to have a gap in the middle. It's not going to be connected at all points on those. Okay, and so that's what it's going to basically look like there for those pieces. So now when you start looking at your equations, you want to identify which one of these is it going to look like. Is it going to be linear, quadratic, cubic, absolute value, or rational? That way, when you go to draw your picture or select a graph, you'll know, hey, I need to be looking for making sure it looks like this shape. So that's a big piece. I would memorize these. We're going to see them throughout the semester. But when we go to graph them, if you have that basic knowledge that what it should look like, then that's going to help you graph it much quicker and know whether your points are correct or incomplete. Okay. All right. So now that we know that information, we can graph. So let's get to graphing here. All right, so examples. We want to graph So number 1. So y equals x plus 3. Again, there are many different ways of graphing. You're going to have to explain whatever way that you decide to use to graph. Now, if the computer says you have to use a certain method, you're going to have to do that. I will teach those methods. Don't worry. Today, I'm going to focus in on one method for all types of equations, no matter what. Okay. And so that's going to be just using tables. We're going to pick some x values, we're going to plug them in, and then we're going to see what the y value is that corresponds with those x values. So that's how we're going to do our stuff here today. Okay. But if later on it's going to give you some specific ways of graphing, and so if it does, you have to follow that method. All right. All right. So here on this one, I said that we're going to use a table of values. And so I'm going to use x and y here on a table. I like to do 3 points when I'm doing that. On the computer, they may only ask for 2. That is okay. If you've done 3, you just pick 2 of the 3, and that will work. All right. Now, when I look at my graph here, if I do not have any fractions, I don't in this case, I'm just going to pick -1, 0, and 1. Okay, so -1, 0, and 1 if I do not have any fractions. If I have fractions, then we've got another issue there, and I'll talk about that in just a moment. Okay. All right, so what we're going to do there is we're going to plug that in for those. Okay, and so we're going to say here for this first one, -1 plus 3. What does that equal? -1 plus 3, that's 2. Right? So we move to the next one there. 0 plus 3. Well, that's 3. And then our last one is 1 plus 3, which is 4. Okay? So now we've created those values. Now, again, the x values, they can be any values you want. You don't have to use -1, 0, and 1. But I like to make my life easy. And so by using those numbers, those are very simple to add, subtract, and multiply and divide with on those. Okay. And so that's why I like to use those numbers. All right. So now we need to graph those. So I need some dashes here. So 1, 2, 3, 4. Now on the computer, that's going to be given to you. They're going to have a little menu where you need to select what type of graph. We know here that this should be a straight line. It's linear because it has an x and a y. There are no powers. There are no fractions with x on the bottom. There are no absolute value symbols. So therefore, we know it's a linear equation. Okay, so it's a straight line is what I should get here for these. And so you'd be able to click that and then create your line from those. Okay. All right, but I'm going to plot my points. So -1, 2. We go -1 on the x up to 2, and that's where we put our point. The next one is 0, 3. So we go to 0 on the x and then up 3. And then finally 1, 4. We go over to 1 on the x and then up 4. And if I've drawn this correctly, then it should be a straight line. Okay. And so there's my graph. We have graphed that equation. All right, so let's do some more. Next one, y equals -5 over 3x plus 2. Excuse me. Now again, I see that even though there's a fraction in front of the x is not on the bottom of the fraction. There are no powers on the x, there's no absolute value. So this is linear, it's a straight line. So we need to create that type of graph, okay? Now we're still, at this point, going to just do a table of values. Now we can pick any values we want. If we were to pick -1, 0, and 1, we would find that for the ones, -1 and +1, we would end up with fractions. And I don't care to try to graph fractions. They're not easy to graph. And a lot of times the computer's not going to have the fraction or decimal or any of those equivalents on there to graph anyway. So when this happens, if we have a graph, a fraction in our equation, we do want to use the 0. That's not a problem. But we want to look at this denominator. That's a 3. So I'm going to pick -3 and +3 because of the denominator. That's where I'm getting these two numbers here. Okay, from that. And so allow that to work for you to help you with those pieces. Okay. All right, so now we're going to do the same thing that we did earlier. We're going to say right here, we do -5/3 times -3 plus 2. Now you have calculators. If you're not 100% sure how to do that on those, you can plug that in the calculator and work through that. But here we're going to see that the 3's cancel out. And so we get negative and negative make positive. So 5 plus 2 is 7. All right, if we take 5/3 times 0 plus 2. Well, 0 times anything is 0. So 0 plus 2 is 2. And finally here, -5/3 times 3 plus 2. 3 and 3 are canceling out, so at least -5 plus 2 is -3. Just by plugging those things in, we've created a good whole numbers there. So let's graph those. Looks like this time I need to go a little bit higher. So 1, 2, 3, 4, 5, 6, 7. Okay. Now when I'm drawing those, you see I'm coming up with these numbers. I know that my X's don't have to really be any further out than 3, but my Y's have to be at least 7 up and 3 down. So I went 7s both directions there. Again, the computer will give you the amount that you need. All right, so our first one is over to -3 and then up 7. Our second one is at 0, 2. And our last one is over to +3 and down to -3. Okay. Now, hopefully I drew them good scale and I get a pretty straight line. My scale's not great there. I didn't probably space things out. Again, the computer will line those up perfectly for you on those pieces. But on your paper, you just want to get it as close as you can for those. Okay. And so that's how we would graph if we have a fraction involved. All right. Well, let's look at a couple of different ones besides linear, so that we know how to handle those as well. Right, so let's see, y equals x squared minus 1. So y equals x squared minus 1. Now we're going to keep the common theme here. We are going to do a table. So I'll look and see here, I do not have any fractions for this one. And so if I do those, x and y, I'm going to do that -1, 0, and 1 to keep it easy for me here. Okay. So we plug those in. So it says -1 squared minus 1. -1 squared is a +1. And then 1 minus 1 is 0. 0 squared minus 1. 0 squared is 0. 0 minus 1 is -1. And then here we get 1 squared minus 1. 1 squared is 1. Minus 1 is 0. Now, hopefully you've recognized by this problem that I'm putting everything that I plug in into parentheses. When you put those things in the computer, it's best practice to do that. Put those in parentheses so that you know that it's doing things correctly. Because if you don't, you're going to end up squaring wrong here and get -2 with those. And that would be incorrect because it's -1 times -1, which is a +1 with those pieces. So make sure, try to always, when you plug something in, put it in parentheses. Okay. All right, so let's draw that graph. We don't have to go very far here. So 1, 2, 3. All right, so our first one. Now you do need to, I'm going to make this side note here. For the parabolas in the computer, you need to plot this middle one first. Okay, it's what we call the vertex. And so you want to do it first. They're going to keep these pretty simple for now. Later on, we're going to have some harder ones in another unit. And so we'll look a little closer on those, but that 0 is always going to be at this point, your vertex. And so we need to plot it first. So 0, -1. And then we can plot the other two. So we had 1, 0, and -1, 0. And we get our U shape right there. Because that's the shape we should have for an x squared. Okay. Now, I haven't really mentioned it before, but on an exam, I would expect to see everything that you see on the board here. I don't need a ton of work, but I do need to see you creating the table. I need to see you plugging the value in at least. I know that you can do that part with the calculator, but this is a minimum of what I would want to see on your scratch paper for an exam. So take that time, draw the table out, show me the work of plugging into that table, and then you can graph those pieces. You don't have to write this one little piece out. That's okay, I understand that. But you need to show that table and plugging in the values for that table, okay? All right, let's do one more, because I know that they try to trick you. All right, so this is absolute value, and we know it should be a V shape. All right, so a V shape here on this one. So if we go to our table here, we have our X and our Y. If we don't see fractions, so our first inclination is to plug in -1, 0, and 1. And if we do that, we will get good numbers, good whole numbers. The problem is we're not going to get a V shape. It's going to be just a straight line, which means it's only one side of my absolute value. We really need to see where is that V created, okay? So we have to be able to look at a few other things. So when this happens on your absolute value ones, only on the absolute value problems here, where we have these bars, what we're going to do is we're going to take this +2. In the middle right here, we're going to do the opposite. Okay, we're going to do the opposite for that. So +2, the opposite of that is a -2. So let me do this in green here. So -2. And then we pick numbers on either side of -2. If we look at a number line, we would have -1 and -3. Okay. And so that's going to be the numbers that we plug in that's going to create my V shape. All right. All right, so now we get -1 + 2. -1 + 2, well, that's 1, +1. So the absolute value of +1 is +1. Next one here is -2 + 2. -2 + 2 is 0. The absolute value of 0 is 0. And finally, -3 plus 2. -3 plus 2 is a -1. The absolute value of a -1 is a +1. Okay, so we do the work inside those bars as is, and then we take whatever the result of that and make it positive. All right, so now we can draw our graph. You don't have to go real far on these. They're not real big numbers. Again, we do need to plot this middle one first. Okay, because of that V shape. It's called, again, kind of like a vertex thing, very similar to the quadratic. So we're going to plot that -2, 0 here. Then it doesn't matter. So I'm going to plot -1, 1, and then -3, 1. There's my V shape. So it's just going to take a little practice with that one. That's probably the hardest in this section because we got to remember a couple of things there on those. But the more times that you can practice it, you'll get comfortable with those things and look for them. Okay. So this is the most basic way to graph. We graph any equations using tables with those. Okay. Again, we're going to look later on other methods based on the type of equation that we have. Linear has some certain attributes. Quadratic has some certain attributes, and we can graph those things accordingly. Okay. And so that will be what you need to do here for this section.